you ask your mum to buy some Cartesian coordinates and she says you've got them at home. When you get home, you find out they're actually spherical. I'm going to show you how to change that up. So here's your two spherical coordinates. They've got these nasty pi's in them. We don't want that. So the first term is called rho. The second point is theta. And the third is phi. And that's the same for this. We then use our general formulas or solutions to work this out. So x is going to be rho cos theta sine phi. Y is going to be rho sine theta sine phi. And z is going to be rho cos phi. So now, if we plug in each of these points into each of these, you're going to get another set, another coordinate vector, but it's in the Cartesian setup instead of the spherical one. So for x, you're going to get 1, because that's rho, 1 rho, dot cos theta, which is pi over 3, dot sine phi, which is pi over 2. That's going to equal, very obviously, a half. Let's now do y. So now that's 1 dot sine pi over 3. And then we're going to do sine pi over 2. And that is pretty obviously root 3 over 2. And z is going to be 1 dot cos pi over 2. And that is 0. Now we have our 3 points. So x is going to be a half root 3 over 2 and 0. So we've now converted this spherical coordinates, these vectors, this vector into a Cartesian. Let's now do it for the y. Same as we did again. I'm going to do x equals 1 here, then cos pi over 4, sine pi over 6, there's going to be a dot there. That's going to equal a root 2 over 4. Yeah, over 4. And then y is going to be 1 dot sine theta, which is pi over 4, sine phi, which is pi over 6, and that is root 2 over 4. Yeah, that's root 2 over 4. Wowza. Then we do the same again, cos pi over 6. So then that's going to be our root 3 over 2. So now we have a root 2 over root 4, root 2 over 4. I keep saying root 4, which is obviously just 2. So anyway, there we go. We now have that is that, that is that. Your mum tried to wreck you, you wrecked her back. It's been a double wreckage, double bluff pars, all that stuff. Coordinates, vectors, come on, come on.